Again, it's a three-step process, and you can see it on your sketching tool. You need to do the vertical asymptote, and then one key point, and then a second key point. Those are your three elements to solving this. So our vertical asymptote is the value of x that makes our input 0. So what value would that be? All right, so we're going to have a vertical asymptote at 6. So I'm going to start with that. Okay, and then I'm going to find my key points. So my first key point is the value of x that gives me a 1 in my input. So what value of x would give me a 1 in here? 7. So there's my first x. And when I plug that in, again, log b of 1 is always equivalent to 0. And again, the way I represent that is 4 to what power is equal to 1? It's always 0. So this whole factor here is 0 times a negative 5 is 0 plus 1 is 1. So here's our first point, 7, 1. So I'll plot that. And then my second key point is the value of x that's going to give me the b value inside my input. So what value of x will give us a 4 in here? 10. When x is 10, I get 4. So 4 to what power is equal to 4? 1. And again, the whole point of getting this second key point is it's equivalent to a value of 1. So 1 times negative 5 is negative 5, plus 1 is negative 4. So here's my corresponding output. And so if I plot that point, 10, and then negative 4, there's my next point. And again, when I sketch this, the computer will sketch it for you, but I approach my asymptote here, and this has the general form of my log function. You guys understand my terminology when I say like that phrase? Like when I'm evaluating the log portion of each expression? You guys understanding what I'm saying there? Yeah. So here, like when we test the 7, so 7 minus 6 is 1. So what we're doing is we're taking log 4 of 1. And so the idea is to use what we talked about earlier. 4 to what power is equal to 1? It's always going to be 0. And then the next one that we test is log 4 of 4. And so when I test, I say 4 to what power is equal to 4? 1. Okay, so we're picking these as our key points because they're easy to mentally evaluate without having to use a calculator. And then you just do your other adjustments, the transformations based on that value. Okay, so when we look at this second example, the first thing I'm going to do is plot my vertical asymptote, which is going to be where? So the value of x that gives you a 0, negative 4. So x equals negative 4 is my vertical asymptote. And then I'm going to find my key points. So my first key point is the value of x that gives me a value of 1 inside my input. So what value of x gives me a 1 in here? Negative 3. And when this is log or base 3 to what power is equal to 1 is 0. So 0 times 5 is 0 minus 6 gives me my output. So negative 3, negative 6 is my first point. And then my second point is the value of x that gives me a value of b in my input. My b value is 3, so what value would x have to be to give me 3? Negative 1. So when I plug that in, 3 to what power is equal to 3? 1. 1 times 5 is 5. 5 minus 6 is minus 1. So here's my second point is negative 1, negative 1 right here. And when I sketch this, it approaches my asymptote here, and it fills the general tendency of a log graph here.